Let's dive right into today's explainer, tackling a massive, real-world challenge. Chapter 3, the Enterprise Research Assistant. We're going to build a production-grade enterprise AI architecture, and we're doing it layer by layer. Honestly, if you've ever wondered how big companies securely deploy AI that searches across all their internal systems without causing absolutely total chaos, well, you're in the right place. Let's get into it.
So, picture this. What happens when your shiny new AI assistant accidentally leaks the CEO's private strategy document to a junior analyst? Yeah, that is the ultimate nightmare scenario. In a corporate environment, a naive AI deployment has a massive blast radius. If you just take all your company data and dump it into a basic AI index, you aren't really building a helpful tool. You're essentially building a data leak engine just waiting to trigger a very, very awkward HR meeting. To make sure that nightmare never happens, here is our architectural blueprint. First, we'll look at the enterprise AI dilemma. Then construct permission-scoped retrieval, build out multi-hop query loops, enforce faithful citations, and finally, scale the whole thing up with multi-agent fan-out. Let's kick things off with Layer 1 and properly define what we're actually up against. Section 1, the enterprise AI dilemma. Think about how much time employees waste just searching across a dozen different platforms to find one single answer. It's a lot, right? The problem is that enterprise data is a completely messy mix of heterogeneous formats combined with incredibly strict access rules. We're talking PDFs, slide exports, threaded support tickets, source code files, random chat messages, the whole shebang. And layered over all of that, strict, constantly shifting permissions. You really can't just plug a basic AI into this and cross your fingers. Which brings us directly to our very first foundational layer, Section 2, permission-scoped retrieval. So why does a simple, naive search fail here? Well, for a few big reasons. Access rules shift literally every single day as people switch teams or projects wrap up. Permissions are also strictly handled on a per-user basis. And going back to that nightmare scenario from earlier, a single leaked document completely ruins trust in the entire system. Because of all this, you absolutely must enforce your access rules at retrieval time before the AI even gets a chance to evaluate the documents. If a source is forbidden, it shouldn't even be an option. This leads us to the golden rule of our entire architecture, what we call the invariant. Simply put, a user must never see a source they couldn't open themselves. We enforce this using a single user identity. That means every single action the AI takes, every search it runs, operates strictly under the asking user's specific permissions. Period. If you can't view that confidential HR file, your AI's search query literally can't see it either. Okay, the data is secure. Now let's go on the offensive and make this AI actually smart enough to handle tough questions. Section 3, multi-hop query loops. In any big company, answers almost never live in just one place. The core policy might be in a wiki, the system owner is listed in the code host, and the actual exception you're looking for is buried in a support ticket. To solve this, our agent relies on the REACT pattern: reason, act, observe. The agent reasons about its goal, acts by issuing a search, observes what comes back, and then asks itself, okay, do I have enough to answer this, or do I need to search again? It essentially stitches facts together across multiple hops. But we absolutely have to put a boundary on this. It's called the bounded loop. If you let an AI search forever, I guarantee it will try to, and that's going to rack up a massive cloud bill and leave your user waiting forever. So we enforce a hard step cap. If the agent can't figure it out in, say, 4 hops, it just stops and escalates the issue. All right, so we've got an agent that can safely and aggressively search across platforms. But how do we guarantee it's not just hallucinating? That brings us to Section 4, faithful citations and guardrails. Listen, in the enterprise space, an uncited answer is a useless answer. The person reading it has to be able to verify where it came from. We call this citation faithfulness, and it is very different from just being correct. An answer might be factually right, but if it points to the wrong source document, it's a fail. Every single claim has to trace strictly back to a verifiable, retrieved source that the user actually has permission to read. To guarantee that faithfulness, we lean heavily on the evaluation and discovery loop. You know, in traditional software, testing is usually that final gate before you ship something. But with AI models being non-deterministic, evaluation has to sit at the very center of your design. We're constantly evaluating component by component, testing the end-to-end task, and monitoring live traffic. If an answer draft is ungrounded, meaning it just doesn't match the sources, our guardrails step in and block it before the user ever sees it. Now, for most everyday questions, a single agent works perfectly. But for those massive, sprawling research tasks, we need our final layer, Section 5, Multi-Agent Research Fan-Out. If you try to force one generalist agent to research a huge topic across wikis, code, tickets, and chats all at the same time, its context window gets completely bloated. It just loses track of what it's doing halfway through. Instead, multi-agent fan-out gives you incredibly tight contexts. You're deploying specialized skills for very specific sources. That being said, multi-agent setups are complex, and they aren't cheap. You only bring them in when they've truly earned their place. You want to use this architecture when subtasks can run in parallel, when the total amount of info blows past a single context window, when searching code needs a totally different skill than reading chat, and, this is key, when the research is high value enough to actually justify the compute cost. So how does this crew actually operate? Think of it like a team. The lead agent is your manager. It takes a broad question, breaks it down, and assigns tasks. The sub-agents are your specialized researchers, firing off at the exact same time to dig through wikis, code bases, and tickets, all still totally restricted by the user's permissions, obviously. Then they report their findings back to the lead, who puts it all together and hands it off to the citation critic. The critic is basically the strict editor, whose only job is to verify that absolutely every claim is backed up by a valid source. And honestly, the results of doing it this way are wild, 90.2%. That is the massive performance edge Anthropic measured when they compared this kind of lead plus sub-agent setup against a standard single agent. A 90.2% boost on their internal research evaluations, that's a real game changer. But there is a catch. It's a very explicit trade-off. Anthropic noted that it beat the single agent, quote, while using about 15x the tokens, and token usage alone explained roughly 80% of the performance variance. So you are directly trading token cost for this incredible capability. That's why you only unleash this multi-agent powerhouse for complex, high-value tasks. If a user just wants to know how to reset their password, you definitely stick to the cheap, fast, single-agent path. And there you have it, the Compose system. We've built out an architecture where every single layer solves a specific piece of the enterprise puzzle. We started with strict, dynamic permissions so your data stays safe. We added bounded multi-hop loops so the agent can piece together complex answers. We built in continuous evaluation and citation guardrails to stop hallucinations in their tracks. And finally, we optimized the hardest research tasks with a multi-agent fan-out. But before we wrap up this explainer, I want to leave you with something to think about. Your agent can now securely read everything the user can. But who is watching your agent? As your system scales up, observability and a completely immutable audit trail become your final and maybe most crucial layer. Every node, every search, every model call has to be traceable. Because in the enterprise world, building an amazing AI is only half the battle. Proving exactly how it made its decisions is the rest of the job. Thanks for tuning in, and I hope this blueprint helps you build some truly smart, safe systems.